The following is the video solution from JSDT Solutions. Question 11.1 says, in the diagram, chords DE, EF, and DF are drawn in the circle with the center O. KFC is a tangent to the circle at F. And the question is to prove the theorem which states that angle DFK is equal to angle E at the circumference. Okay, so just based on what they are asking for, notice that this is on the left-hand side, okay? Since they want us to prove that DFK, this angle over here, is equal to this angle, here's how we're going to draw this diagram. You see, the angles that we're going to create are going to have to be focused at this point over here. So we're going to first of all draw a diameter. And the diameter is going to be connecting this radius OF, and it's going to just extend all the way to this point, which we can call anything really. So I'll call that P, a point P. Okay, now remember the angle needs to be focused on this side, since the angle we're trying to prove it's equal to is this angle over here. It's on the left, so you need to focus on the angle on the left as well. So what we're going to do is draw a line joining P and E together so we can create another angle at the circumference there, and that's going to help us to prove this. Okay, and then it's important to just make sure that you write down any constructions that you have made. So let's go ahead and write that down. Okay, so draw diameter PF and line PE. Okay, so we are required to prove that the angle between the tangent and the chord is equal to the angle supported by that same chord. Of course, you have to do this without actually using that theorem. So let's go ahead and name these angles. So we can call this angle F1, and that's angle F2, and this is angle E1 and angle E2. So looking at angle F1 and angle F2, if we add them up, they will give us 90 degrees because the line from the center of the circle to a tangent is perpendicular to that tangent at the point of contact. So we can tell them that angle F1 plus angle F2, that they add up to 90 degrees. And that is because we have a radius being perpendicular to the tangent at the point of contact. Okay, so that is down first. And we also have another case going on here. It's not the same case, of course, but they also add up to 90 degrees. Angle E1 plus angle E2 will give us 90 degrees for a different reason. And the reason for that is because PF is a diameter. And so angle E1 and E2 are jointly the angles supported by a diameter. So it's the angle in a semicircle. So we can also see that angle E1 plus angle E2, that they also add up to 90 degrees because of angle in a semicircle. Okay, now that we have shown them that they both add up to 90 degrees, this does not prove that they're equal yet. However, if we can prove that one of them, one set is equal, like F1 is equal to E1, or that F2 is equal to E2, it would mean the other pair would be equal as well. So that's what we're going to focus on. Let's look at those angles and see how are they actually equal to each other. Okay, so looking at it like that, you see that angle E2 is supported by this arc DP. But we also have another angle at the circumference supported by DP, and that is angle F2. So that will mean that they are equal because of angles in the same segment. So angle F2 is equal to angle E2 because of angles in the same segment. Okay, angles in the same segment are equal. And now since we've got one pair being equal to each other, that automatically proves that F1 is equal to E1 since they have to both add up to 90 degrees. So it's kind of like this, let's say it was 60 degrees. And then we also found that, okay, since they're equal, E2 is also 60 degrees. So that would mean that F1 and E1 both have to be 30 degrees for them to add up to 90 degrees. Okay, and that's how we prove that. So therefore, angle F1 is indeed equal to angle E1. So that means we can finally conclude angle F1 was the angle DFK and angle E1 was the angle E. So we can finally just tell them that this means that angle DFK is indeed equal to angle E. And that is how we prove this theorem. Question 11.2 says, in the diagram, PK is a tangent to the circle at K. Chord LS is produced to P. N and M are points on KP and SP respectively, such that MN is parallel to SK. Chord KS and LN intersect at T. And the first question is to prove, given reasons, that angle K4 is equal to angle NML. Okay, so let's look at the diagram. Okay, so angle K4 is here. So it's the angle between the tangent and this chord KL. So it's going to be equal to the angle at the circumference in this circle supported by this same chord KL, which we can see is this angle S1. Okay. From angle S1, where is S1? It's at the circumference, yes, but you see that it's also next to this parallel line. So we can go ahead and use fun angles here. So angle S1 is this angle over here. So it's going to be equal to this entire angle because of corresponding angles. It creates an F. So that is angle NML. Okay, and that is why they are equal. So we can go ahead and tell them that angle K4 is equal to angle S1 because of the tan chord theorem. So angle K4 equals angle S1 because of the tan chord theorem. And then we also know now that angle S1 is equal to this angle over here, which is angle NML because of corresponding angles on parallel lines. So we can tell them that angle S1 is equal to that angle NML, and that is corresponding angles. So corresponding angles, and make sure to state the lines that are parallel. Okay, because MN is parallel to SK. And now, because these angles, angle K4 is equal to angle S1 and angle NML is also equal to angle S1, it would mean that they are both equal to each other. So we can finally conclude that this means that angle K4 is indeed equal to angle NML. And that is our answer. Just ensure that you also leave these because it's probably going to help you with the next question. Okay, moving on to the next question. And then B says we need to prove that KLMN is a cyclic quadrilateral. Okay, so that is this quad over here. Okay, so since we are looking at that, and I guess here it's already very clear, but just remember the three theorems that you have to prove that a shape is a cyclic quad. And here they are. If we can prove that the exterior angle of this quad is equal to the opposite interior angle, then it is a cyclic quad. If we can also prove that the opposite interior angles add up to 180 degrees, then it is also a cyclic quad. And lastly, if we can prove that the angles in the same segment, meaning those angles at the circumference supported by that same chord or arc, that they are equal, then it's also a cyclic quad. But in this case, it is quite clear because we can see that the exterior angle of this quad is actually equal to the opposite interior angle. This is something we've already proven. We show them that angle K4 eventually is equal to angle NML. So in this case, we can just go with this theorem. So we're concluding that we're telling them that angle K4 is equal to angle NML, which is the exterior angle. And that has been proven already in the previous question. So we can tell them this has been proven. And because of that, that would conclude that KLMN is indeed a cyclic quad. And the reason is because we had the exterior angle being equal to the opposite interior angle. So therefore, it is a cyclic quad. And there we go. We have proven that the shape is a cyclic quad. Moving on to the next question. Question 11.2.2 asks us to prove, given reasons, that triangle LKN is similar to triangle KSM. So let's go ahead and highlight those triangles in our diagram. Okay, so in this diagram, remember that, and this is probably why I shouldn't have erased those lines, but remember that we have already proven that the shape KLMN is a cyclic quad. So we're going to focus on that as a cyclic quad because it's just going to give us more information and more room to make angles equal to each other. So if that shape is a cyclic quad, let me highlight it. Now in the cyclic quad, focusing on, because we need to focus on the angles. And one way to focus on the angles is to just look at how they were named. These angles were named as triangle, LKN, and KSM, meaning they're similar in that order. Okay, so I've pinned it to the screen and we can just look at it like that. So here are our triangles. If we're looking at it like that, then it means that the L in this one triangle will go with a K in the other triangle. So L will be this angle over here, and the K in this triangle, the blue triangle, would be K2. So let's look at those and see how are they equal. Well, first of all, we know that this shape is a cyclic quad. So do you see that from one end of the quad, if we connect it, we have one diagonal here, and then we have another one. And now with these, we can see that this forms angles in the same segment. Okay, so this would be KN, that's the chord supporting the angle, angle M2, and this angle, angle L1, okay, in that cyclic quad, the green cyclic quad. So those would be equal. So now we have moved from angle L1 to angle M2. Now notice that angle M2 is next to a parallel line. So we can form alternate angles over here. And there we go. So angle M2 is equal to angle K2. So let's go ahead and start off with that. We'll introduce our triangles and then show them that those two angles are equal. Okay, so in this, we're first saying that we have angle L1 being equal to angle M2 because of angles in the same segment in that cyclic quad that we have. So angle L1 is equal to angle M2, and this is because of angles in the same segment. And then we have angle M2, so we've already shown that these two are equal. Then angle M2 is equal to angle K2, and that is of course because of alternate angles. And we'll just tell them the lines that are parallel as well. Okay, so just tell them that angle M2 is equal to angle K2 because MN is parallel to SK, okay? And so because these two angles are both equal to angle M2, that concludes that angle L1 is equal to angle K2. And those are two angles in those triangles. So we found these two. And then we need to find another pair that are equal. Now, this is actually still using this same theorem. Okay, you see in this cyclic quad over here, because of the lines going across, then we also have this situation where the angles in the same segment are equal. So angle M3 is equal to angle N3. Okay, so we can go ahead and tell them that. Okay, and that is in each triangle. So angle M3, this angle over here, is equal to angle N3. And that is also because of angles in the same segment. And because we have two angles in each triangle being equal, that and that those two are equal, then by default, the other two angles will be equal in each triangle. So we can finally just tell them that this last angle would be equal. It was LKN and KSM. So the other angles that we didn't really speak about yet was this angle here. Okay, all of that is actually equal to this angle, angle S2. Okay, so we can just tell them that. Let's just go ahead and call this angle LKN. So angle LKN is equal to angle S2 because we have two other angles equal. And your reason here can either be third angle in a triangle, or it can be the sum of angles in a triangle because they should add up to 180 degrees. So by default, they are equal. Okay, so with these three angles being equal in each triangle, then this finally concludes that triangle LKN is indeed similar to triangle KSM. Okay, and that is because of we have 3 sets of equal angles. So angle, angle, angle. And that is our answer. Moving on to the next question. Question 11.2.3 says, if LK is equal to 12 units and 3KN equals 4SM, determine the length of LK. Okay, so we can just put down the diagram, but first, let's just unpack what this means. If they say 3KN equals 4SM, then this is a ratio they're giving you. So you're supposed to have a length over a length, okay, that ratio is equal to a specific value. So we're going to divide both hand sides by, we're trying to keep letters on this side. So this is the letter on this side. We can just divide both hand sides by SM. And now that we'll have KN over SM and these would cancel, we want the numbers to stay on this side. So we have 4 here. The 3 needs to also come this side. So we can divide both hand sides by 3 as well. So this concludes that the ratio they're giving us is KN over SM is equal to 4 over 3. Okay, let's just get our diagram so we can better understand the information they are giving us. Okay, and the lengths they have given us, they gave us LK. So LK has been given, it is 12 units. And we have this ratio now. So this will just represent it as a ratio in the diagram. So instead of calling it 4, so there's no confusion with this. This is 12 units. That is just 4 as a ratio. So by KN, we can just call this 4A. And then SM, that's 3A. Okay, so looking at the proportions that they've given, you can see that they are using the 2 triangles which we proved was similar in the previous question. So we're going to go ahead and use that, okay, the proportions there, and we will find the lengths that they're referring to. Okay, so since this is what we already showed them, we can pick LK since they gave us that length. Now, if you take LK, you have to take this over KS. So they are really in proportion. So we're saying over KS that this is equal to, and then what else did they give us? They gave us the ratio of KN and SM. So we're going to have to take KN. And as you can see, when you take K and N, then the corresponding side is SM indeed. Okay, so that's SM. And that's what we have here. We have KN and SM. So because we have this, we can finally just conclude. And when we say this, we're going to, of course, have to tell them that this is because of similar triangles. So we can tell them it's because we had similar triangles. That's why we are able to use these proportions. Okay, specifically, these triangles were similar. So with this, we can go ahead and substitute. So LK is 12 units, as we have it there, 12 over KS, and KS is what we are looking for. That's the length. So we'll leave that as KS is equal to, and we know now that KN over SM is 4 over 3. So that is 4 over 3. And then you see that in order to solve for KS, we can start by cross multiplying. So that's going to be 4 KS is equal to 12 times 3 is 36. And then divide both hand sides by 4. Therefore, KS is equal to 36 divided by 4 is 9. So that's 9 units. And that is the length of KS. Question 11.2.4 says, if it is further given that NL equals 16 units, LS equals 13 units, KN equals 8 units, determine with reasons the length of LT. So let's just go ahead and get this diagram, and we'll also just remember that KS is actually equal to 9 units. Okay, so KS is already equal to 9 units, so just keep that in mind. But they're telling us that LN or NL is equal to 16 units. So that is this length over here. That is 16. So this is 9, this one. This is 16 units, so keep that in mind. And then they also tell us that LS is 13 units. So LS, this part is 13 units. And then we are also told that KN is 8 units. So KN is 8 units. Okay, that actually helps a lot. So them telling us this can actually help us to find out what exactly A is. And then anything in terms of A would also be able to be found. For example, like MS. Okay, so let's see how we can use all of this to determine the length of LT. Okay, so if we're just trying to find the length of LT, so we just want LT, this part over here, then it means that you see the triangle we can actually use to find this. We can use this triangle LNM, because this triangle has a line drawn parallel to one side of it. So we can use the proportionality theorem over here. Now, in order to use that, when we're trying to find LT, so since this is missing, that's fine. We would need one of the lengths on this line. Now, they gave us the length of LN. So that's great. We can use LT over LN. Then on the other side of this triangle, this side, we would also have to have LS, which we do have. It's 13 units. And then this needs to go over LM. Okay, and then that's where the struggle seems to be. So we just need to find the full length of LM. If we can find that, then this is sorted. Okay, so to find LM, we need MS. But here's the thing. We were told the length of KN. So remember how in the previous question, we were able to use this, right? Because we knew that Kn over Sm is equal to 4 over 3. Okay, this was proven in the previous question. We can use this now to finally find the length of Sm, since we know what Kn is. Okay, so let's go ahead and use this ratio as it is. Okay, so I'll just go ahead and say since, and I'll go ahead and rewrite that. So since Kn over Sm is equal to 4 over 3, then we're just looking for Sm, knowing Kn. So Kn is 8 units over Sm. What we're looking for is 4 over 3. And now we can cross multiply. So that is 4 Sm is equal to 24. And then if you divide both hand sides by 4, then Sm is equal to 6 units. Okay, great. Now that we know what Sm is, we know the entire length of Lm, which is what we needed. So we can therefore say that Lm is therefore equal to 13 plus 6, which is 19 units. So Lm is 19 units, and that's going to help us. Okay, so with this, the only reason we would have here is that this was something that was proven in the previous question. So we'll just keep that there. Okay, and now let's go ahead and use the proportionality theorem on this. So looking at this again, you're using this triangle, and we're just going to go ahead and say we're taking LT over Ln, and this is equal to Ls over Lm. And the reason for this is the proportionality theorem. So we can just say this is because of the prop theorem. Okay, and let's go ahead and substitute. So LT is what we are looking for. We'll leave that empty. So LT over Ln, that is this entire length, which they told us was 16 units. Okay, so we'll say over 16 is equal to Ls, and Ls is 13. So that's 13 over Lm, which we found to be 19. And now we can finally find the length of LT. So you can just multiply both hand sides by 16 to get rid of that, since it's in the denominator. So LT is finally equal to, and if we multiply them, we get 208 over 19, but as decimals, we'll just round off to 2 decimal places. We can, of course, state that first, that this was 208 over 19, but for a better understanding of this length, we can put it in decimal form. So this is 10 point, and that's going to round that 4 up to a 5. Okay, that 7 rounds it up. So we have 10.95. And these, what unit of measurement were they in? They were just in units. So it is 10.95 units. And that is our answer. And that is it for question 11.